Hey, welcome. Today we are tackling a skill that is absolutely essential for anyone in healthcare. Dosage calculations. You know that moment, right? The doctor's order says one thing, the drug label says another, and you're in the middle. Well, we're going to clear all that up. By the end of this, you'll have 3 solid methods to solve these problems with complete confidence. Let's do this. So here's our game plan. First, we'll look at the exact challenge we're facing. Then we're going to walk through 3 different ways to solve it, step by step. And finally, I'll show you how to pick the best method for any situation and give you a final checklist to make sure you get it right every single time. Okay, let's jump right into a classic scenario. The doctor orders 0.5 grams. You look in the med drawer, and all you have are 250 milligram tablets. The units, they don't match. This isn't some rare puzzle, you guys. This is a daily reality in healthcare. Getting the right answer is absolutely non-negotiable for patient safety. And that's really the core of it. This mismatch isn't a mistake. It's just how things work. The prescriber thinks in grams, the pharmacy supplies in milligrams, and you are the critical safety stop that has to bridge that gap. This isn't just about passing a test, it's about protecting your patients, every single shift. All right, let's start with our first tool in the toolbox, the basic formula. Think of this as your go-to for simple, straightforward problems. It's clean, it's easy to remember, and it's a fantastic place to start. The formula itself is just D divided by H times V. You can just remember it as D over H times V. Super simple, and it works perfectly for a lot of common situations. So let's break down what each of those letters actually stands for. It's really intuitive. D is for the desired dose. That's what the doctor ordered. H is for what you have on hand, what the drug label says. And V is for the vehicle, which is just the form the medicine is in, like 1 tablet or 1 ml of liquid. Okay, let's see it in action. Let's say the order is for 500 milligrams. You have 250 milligram tablets, so desired is 500, what you have is 250, you just plug it in. 500 divided by 250 times 1 tablet for the vehicle, and that gives you 2 tablets. Simple, right? But, and this is a huge but, here's the catch. The basic formula cannot, I repeat, cannot handle unit conversions on its own. It only works if your desired dose and your half dose are already in the same units. You have to do that conversion from grams to milligrams yourself before you even start. And that extra step, well, that's a spot where errors can creep in. So that brings us to our second method, the ratio proportion approach. Now, if you're a visual person, somebody who really likes thinking in fractions, this one might just click perfectly for you. It's just a different way of looking at the exact same problem. Here's the setup. You're basically creating 2 fractions that are equal to each other. On one side, you put what you have, the dose on hand over the quantity on hand. And on the other side, you put what you want, the desired dose over X, which is just the unknown amount we're trying to figure out. And the process is a simple 3-step dance. First, write the fraction for what you have. Second, set it equal to the fraction for what you want, using X for your unknown. And third, you just cross-multiply and solve for X. That's it. Let's use our same example. We have 250 milligrams per 1 tablet. We set that equal to the 500 milligrams we want over X tablets. Now, we cross-multiply. 250 times X equals 500 times 1. So 250X equals 500. A little quick division, and boom, X equals 2 tablets. See? Same problem, same exact answer, just a different way to get there. All right, time to level up. This is the pro method, dimensional analysis. Honestly, this is the ultimate tool because it brilliantly solves that whole unit conversion problem. If you're going to master just one method, make it this one. It's the gold standard for safety, and it's your best friend on exams. The idea behind dimensional analysis is just so elegant. You set up a long multiplication problem with a bunch of fractions, but you arrange them in a very clever way so that all the units you don't want, like milligrams and grams, cancel each other out, leaving you with only the unit you do want in the final answer. It's like a self-checking system. It's beautiful. So how do you build one of these equations? It's really just 3 pieces. You start with what's on the drug label, that's your vehicle over what you have on hand. Then, and this is the magic part, you add a conversion factor if you need it. And finally, you multiply by the doctor's order. Okay, let's go all the way back to our very first problem. The order was 0.5 grams, and our supply is 250 milligram tablets. Here's how we set it up. We start with what we have, 1 tablet per 250 milligrams. Then we add our conversion factor. There are 1,000 milligrams in 1 gram. And finally, we multiply by the order, which is 0.5 grams. And now for my favorite part. Watch the magic. The milligrams on the bottom of the first fraction cancels out the milligrams on top of the second. The grams on the bottom of the second cancels out the grams on top of the third. What's the only unit left standing? Tablets. It's exactly what we wanted to find. From there, the math is easy, and it gives us the right answer. 2 tablets. This is why this method is so powerful. Okay, so now you have 3 powerful methods in your toolkit. The big question is, which one do you use and when? Well, it's really all about picking the right tool for the job that's right in front of you. Here's the simple rule of thumb. If the units in the problem already match, go ahead, use the basic formula or the ratio method. They're fast, they work great. But the second you see different units, like grams and milligrams, your brain should immediately switch gears to dimensional analysis. It is the essential and much safer choice. I mean, this chart really says it all. Can it handle unit conversions? Only dimensional analysis gets a yes. That's what makes it the most flexible. And that's why, critically, it is the best method for exams like the NCLEX. It forces you to show your work and track your units, which makes it so much harder to make a simple, silly mistake. So let's just boil this down. For any test, for any clinical situation, here's your key takeaway. If the units are different, you always use dimensional analysis. It's your safety net. And no matter what method you use, get in the habit of labeling your units as you go. It's a simple little thing that will save you from so many headaches and make sure your final answer actually makes sense. And finally, before you ever act on a calculation, let's build in one last little safety check. Think of it as a quick mental checklist you can run through every single time just to be sure you've got it right. Okay, make this your habit. Before you do anything, ask yourself these 3 questions. Number 1, did I label all my units? Number 2, is my final unit correct? Am I looking for tablets or am I looking for ml? And number 3, if there was a unit conversion, did I use dimensional analysis? That little 2-second pause is your final line of defense against a met error. Because that's what this all comes down to, right? This isn't just about math class or passing an exam. The right calculation is so much more than a number. It's the very first step in providing safe, effective patient care. It's a foundational skill that you'll use to protect lives. Thanks so much for joining me.